So welcome back community, myself Ritik Singh. So in previous video we were saying that how what is JVM, what is JDK, what is JRE and what is Java. Simply we will in our last video we see what is Java and why Java is called secure language, portable enterprise language and robust language in exception handling concept and many of the new concepts. So be with me till the end of this video. You will cover up we will try to cover up new concept in very depth. We will try to understand what is Java, how Java works. We will write many codes and understand the logics, and also we will try to cover our theory in this video. And in next 10 videos you will get lots of theory, and after 10th video we will do coding. Also we will cover the new modules Maven, Kafka, Kubernetes and Terraform, and we have multiple modules like we will cover this. I will share with you. I'm sharing now with you, so let's talk with some of them. So Springboard, Spring Web, Spring Security, Spring Data JB, Spring Cloud, and we have Hibernate, Liquibase, Jackson, JUnit 5, Mockito, Test Containers, Micrometer, Lombok, Logbit, and Jenkins, Division, Resilience, Forget, Spring Cloud Gateway, Quirkus, Micronet, Hidden, Terraform, Ansible, Argo CD, Garafana, Kilo Clock, Kong, Vault, Jenkins, Git, Web3J, 3G, Hyperledge Fabrics, SDK, Coda, Bitcoin J. So we have many modules. We will try to cover all these modules. I know. So let's start this beautiful video. Be with me till the end of this video. So you going to master in this language. So let's start this video. So let firstly quick forward and understand the definition. So what is class part? Describe the location where required class part uses class part to locate required classes. What is class path and why you use class path? So simply describe location where required classes files are able to compile, and then use class path to locate the required classes path. Path describe the location where binary executable is available. Inside JDK executors are available. Virtual machine. Virtual machine is a machine which does not physically exist in your computer. It simply use the resources of your physical machine and simply run as a software implementation of a of a physical machine. It simply uses your physical resources of your PC, of your laptop, your desktop, and it's totally isolated with your system. Both two systems are isolated. You can simply run multiple operating system in your virtual machine. They all are separated to each other, isolated to each other. No involvement of this. Simply they use it as physical uh, resources. Vora is the right ones and run anywhere concept, which runs on virtual machine. That's mean that na virtual machine, like if you run Java is a platform independent language. So if you write a code in your system, that this code will be run in on system all over the world, all over all the system in all systems. Simply JVM is very good concept. The compile will converting a Java file into a Java.class file. The .class file is an input to the JVM which loads and executes the class file. Hardware system based virtual machine, we have multiple kernel हो गया, PL हो गया, CLR, Java Virtual Machine, JVM. JVM is the part of GRE and is responsible to load and run class files. Class loading subsystem is the system which is responsible to load class. Loading, linking, initializing. Loading means that loading is simple process class file to store corresponding data, binary data in the method area. For each class file, JVM will store corresponding information in the method area. Fully qualified names of class, fully qualified name of parent class, method of information, variable information, construct information, modifier information, construct tool information. After loading .class file, immediately JVM creates an object which for that, in a heap memory of type java.line class, the class object can be used by compiler programmer to get class level information like method information, variable information, construction information. Example, you can simply see this code and try to run in your computer. This is the total the code. You simply copy from here. You will and try to run this in your PC. We do not have enough time to discuss this code, so simply see that class loader subsystem. So we have in here class loader system loading, bootstrap class loader, extensive class loader, application class loader. Linking is the process verify, prepare, resolve, initializing class file. stack area, runtime data areas, PC register, native methods, stack, heap area, method area where the qualified class names are stored, Java JIT, Java in time, just in time compiler, interpreter, what is profiler, garbage collector, native method interface, native method library, Java, JVM, student.class info, customer.class info, class object to represent student.class info. It is not student object but class object. Customer.class info, class object to for customers and represent customer.class info. It is not customer object, it's also class object. Class file in a hard disk, class loading. It's a simple another code you will try to run in your PC and you will understand the concept. You simply try your own self to run this code that's help you to understand Java more deeply. For every loaded type, only one class object. For every loaded type, only one class object will be created even though we are using the class multiple times in our program. Simply linking. Linking consists of three activities we see in diagram: verify, prepare, and resolve. What is verify? Verify, it is a process ensuring that binary representation of a class is structurally correct or not. This is JVM will check whether .class file is generated by a valid compiler or not, whether .class file is properly formatted or not. Internally, bytecode verifier is responsible for this activity. Bytecode verifier is the part of class loader subsystem. If verification fails, then we will get runtime exception. So if this verification failed, we will get runtime exception. Verify that the code is generated, the code dot class file is generated by compiler valid or not. Simply. What is preparation phase? In this phase, JVM will allocate memory for class level static variable assign default values. Initializing phase, original value will be assigned to the static variables. Only default values will be assigned. Simply, you understand. Resolve resolution. It is the process of replacing symbolic name in our program with original memory reference from method area. So simply in in previous slide, we see that our qualified class names and other things are stored in method area, like qualified variable names, variable information, and all stored in method area. So simply symbolic names replaced by original memory reference from method area. Simply you can run. For the above class loader load resolve.class, student.class, string.class, object.class. The name of these classes are stored in constant pool. So simply dot class files, names of these classes are stored in constant pool of resolve.class. In resolution phase, these names are replaced with original memory level reference from method area. Initialization. In this, all static variables are assigned with original values and static block will be executed from parent to child, top to bottom approach. Simply class loader, subsystem loading, bootstrap class loader, extension class loader, application class loader, linking, verify, prepare, initializing, resolve. Class loader subsystem is that only. While loading linking, if any error occur, then we will get runtime. In that, we will get runtime exception. Type of class loader. Class loader subsystem contains following three type of class loader: bootstrap class loader, primordial class loader, extension class loader, application system class loader. Bootstrap class loader, it is responsible to load core Java API application interfaces classes. These classes API classes are present in rt.jar and the location path of rt.jar is called bootstrap class path. Bootstrap class loader responsible to load class from bootstrap class path. So simply we see here rt.jar. What is rt.jar? Simply we go to on ChatGPT and ask what is rt, what is rt.jar in Java. We check what is rt.jar. We use AI in this because AI help us to understand the concept in more depth. So we take some help from AI. AI help us to boost our productivity 10x and 100x. We know that now model is trained on million of billion of parameters that we have. We know that and ChatGPT is trained on 175 billion parameters. That's the basic version at that time. So now you know that now how much parameters having ChatGPT. So what is RT stand for? Runtime. Okay, RT stands for Holy Grail of file of Java runtime. What does it stand for? RT stands for runtime. It's executable jar file that contains all compiled files for the core Java environment. Where does it live? It located in jre.lib library directive Java, where when you start any Java program, the bootstrap class or the first loader will be discussed immediately. Look for file to load the fundamental class. So you can simply what is you see a term here char file. What is char file? You know, let's ask what is jar file. What is jar file? Think of this Java version of zip. It is a package file format used to aggregate many Java class metadata and resources like tags, image configuration into one single file. That's called a char file. Java archive is called char file. So let's move on our PPT. Booster class loaders are by default available with every Java. It's implemented in a native language like C, C++, and not in Java. Okay. JDK, GRE, Java Runtime Environment, Library, runtime.jar file, Java Archive, Extension Class Loader. Extension Class Loader is a child class or bootstrap class loader and it is responsible for loading classes from extension class path JDL, JRE, lib. So JDK, JRE, lib, extension jar.file. Extension class loader is implemented in Java and corresponding to class file is sun.music launcher extended load class loader. Application subsystem class loader. System application class loader is the child class of extension class loader. This class loader is responsible to load classes from application class path. It's internally uses environmental environment variable class path. Path we set in system settings. Application loader is implemented in Java and correspond dot class file. Bootstrap class loader, extension class loader, and application class loader. How does loader works? Let's understand this. Class loader follow delegation hierarchy principle or algorithm. Whenever JVM comes across a particular class, first it will check whether the corresponding class file is already loaded or not. If it is already loaded in method area, that then JVM will consider that loaded class. If it is not loaded, then JVM request class loader to load that class. Then class loader subsystem hand over that request to application class loader. Application class loader delegate the request to extension class loader, which in turn delegate the request to bootstrap class loader. Then bootstrap class loader will search in bootstrap class path. If it is available, then class will be loaded by bootstrap class loader. If it note that bootstrap class loader delegates the request to extension class loader will search in extension class path. If it is available, then it will be loaded. Otherwise, extension class loader delegate the request to application class loader. Application class loader will search application class path. If it is available, then it will be loaded. Otherwise, runtime exception will be there. No class definition found error. Class not found exception we get. Simply we can see the diagram. Bootstrap class loader. First application class loader, then extension class loader, then bootstrap class loader. Then delegates to extension class loader and then gives to application. If that is not, then we will get runtime error. Simply you can run that code and check it is not working or it is working or not. If you have class or not, simply you can check. Runtime memory areas of JVM. Okay, that's very important concept. Runtime memory area of JVM. Runtime memory area of JVM. Since we talk about method area, this shared resources, one per JVM instance, it store all the blueprints, class structure, method data, static variable, and runtime constant pool. The library construct instruction manually for every object you will create. Heap area, this is also shared resource and it's usually the largest part of the memory. What inside all objects and their correspond instance variable created using the new keyword new. Analogy, the actual factor floor where the physical product object live. This is where the garbage collector does its cleaning. Stack area. Unlike the heap, this is not shared. Every time a new thread starts, the JVM create a private stack for it. Stack frames. Every time you call a method, a new frame is pushed onto the stack containing local variable partially with the partial result. Once the method finish, the frame is pop deleted. Analogy, a person to do list. So simply we can go to our this slides PPT. Whenever JVM loads and runs JVM program, you need memory to store several things like bytecode, object. What is bytecode? What is bytecode? You know that bytecode? Yes. What is bytecode? What is bytecode? And check. Bytecode is the intermediate represent of Java code. It's the magic that makes Java platform independent. That is the magic that makes Java platform independent. The compiler does not translate your code into machine code, which only a specific CPU can understand. Instead, it translates it into bytecode, which is saved as .class file. The middleman role. Think of it as a universal language like English. Source code Java, human readable. Bytecode. Class file, Java readable, high optimized set of instruction. CPU readable, over zeros and one your hardware understand. Why is it called bytecode? It is called bytecode because each instruction is typically 1 byte long. This makes the file compact and easy for the JVM to transmit over network or load from disk. A key characteristic in the platform security purpose. So Java just in time. So simply we will back to our memory. We have method area, object. JVM is stored into following 5 categories: method area, heap, stack, PC, native method area. For every JVM, one method is available and it's created at the time of JVM startup. Inside of method area, class variable binary data encoded static variable will be stored constant. A class will be stored inside method area. Method area can be accessed by multiple threads simultaneously. Heap area. For every JVM, one heap area is available. Heap area is created at the time of JVM startup. Object and corresponding instance variable are stored in the heap area. Every area in Java is object only, hence. Array is also stored in the heap area. Heap area can be accessed by multiple threads and hence the data stored in the heap area is not thread safe. Heap area need not be contiguous. Heap memory stack. Let's see. Java application can communicate with JVM by using runtime object runtime class in Java. In single is singleton class, and we can create runtime object as follows: our runtime r runtime.get runtime Java application and JVM, and that the runtime object. That's the runtime communication. Once we get runtime object, we can call following method on that project. Max memory, it returns the number of byte of max memory allocated to the heap. Total memory returns the number of byte of total memory allocated to the heap. Initial memories. Free memory returns no byte of the free memory present in the heap. You can simply copy this simply copy this code and try to run, and you will get some values in MB. Setting minimum and max heap size. Heap memory is finite fixed memory, but based upon a requirement we can set max and min heap size. That is, we can increase or decrease fixed based on our requirement. We can use following flags with Java command: examx to set max heap size. Java. This command will set max heap size as 515 MB. Examx to set min heap size. To set minimum heap size as 64 MB. Total memory execution. This stack memory area. For every thread, JVM will create a separate stack at that time of thread creation. Each and every method call performed by that thread will be stored in the corresponding stack, including variable. After completing a method, the corresponding entry from the stack will be removed. After completing all method calls, the stack will become empty and that empty stack will destroy by the JVM just before terminating that thread. Each entry in the stack is called frame or activation record. Simply you can run this code again. Data stored in stack is available for the corresponding thread only, not available to the remaining thread. Therefore, this data is thread safe. The data stored in stack is available for corresponding thread only, not available to the remaining thread. Therefore, this is thread safe. Stack is thread safe. Stack frame structure. Each stack frame contains three parts: local variable, operand stack, frame data. Local variable array, public void this and long. So this is called local variable array. Main function stack frame activation decode. Main method M1, main method M1, M2, runtime stack memory. Stack follow LIFO last in first out principle. It contains all parameters and local variable of the method. Each slot in the area arrays is of 4 byte values of type int, float, difference of occupy one entity in the array. Values of double and long occupy two consecutive entries in the array. Byte, short, and char values will be converted to into type before storing and occupying one slot each. But the way storing Boolean values verified from JVM to JVM. But most of the JVM follows one slot for Boolean evidence. Local variable array, operand stack, frame data. So each block of 4 byte local array, variable array, int, double, object, float, long. Operand stack. JVM use operand stack as workspace. Some instruction can push values to operand stack, and some instruction can pop values from operand stack, and some instruction can perform requirement operation. Like you can see this example, like program I load 001, I add, I store. This is the program you are writing, and you then instruction add. Before starting local variable 190 operand stack local variable after I loaded 190 in your stack. Operand stack you get 100. Simply you can see the instructions. Then after I1 loaded local 190 operand stack you have 90 and in the last. Then local variable array after I added 190 you will get 190 and the operation you perform last. Then after I dot store you simply store that the final value in your stack. Frame data, open stack is that. Frame data is contains all symbolic reference related to the that method. It also contains a reference to exception table which provide corresponds cache block information. In the case of exception, program counter, PC register. What is program counter? Program counter is not a very difficult term. It's very simple. It stored the instruction of the next one of previous. For every thread, a separate PC register will be created at the time of thread execution. PC register contains the address of current execution instruction. Once instruction execute automatically, PC register will be incremented to hold address of the next instruction. Let's also follow the instruction of the next instruction. Native method stack. For every thread, JVM will create a separate native method stack. All native method call invoked by the thread will be stored in the corresponding native method stack. So what is for every thread will create a separate native method stack created. All native method call invoked by thread will be stored in the corresponding native method stack. Method area, heap area, stack area are considered as important memory areas with respect to the programmer. Method areas and heap areas as per JVM, whereas stack areas, PC registers, and native method stack as per thread. So static variable stored in method area, instance variable stored in heap area, and local variable in stack. Execution engine. This is the central component of JVM execution engine responsible to execute Java class file. Execution engine mainly contains two components. Interpreter. What is interpreter? Middleman is that? No. It is responsible to read bytecode and interrupt into machine code. What is interrupt? Let's check it. Interrupters. So what is interpreter? Interrupter and interpreters. Sorry. What is? Okay. In the Java, because the interpreter is the command of execution that read bytecode execute. When you run your W1 class using the java.1 command, the interpreter takes dot class file. It reads one instruction 0 a.load 0 invokes special. It converts that instruction into machine code for your specified OS. The CPU executed and interpreter moves to the next line. Advantage fast startup, memory efficiency, slower execution, line by line is slower than running pre-compiled machine code. If method is called 100 times in a loop, the interpreter translates 100 times. The hybrid solution interpreter plus GIT. We use GIT. So let's see what is GIT. It is responsible to read by bytecode and interpret into machine code, native code, and execute that machine code line by line. The problem was interpreter is the interpret every time even same method invoke multiple time which reduce performance of the system. To overcome this problem we have JIT, just in time compiler was introduced in version 1.1. The main purpose of JIT compiler is to improve performance internally. JIT compiler maintains a separate counter for every method. Whenever JVM come across any method call, first that method will be interpreted normally by interpreter and just in time increment the corresponding count values variable. This process will be continued for every method. Once if any method count reaches threshold value, then JIT compiler identify that the method is repeatedly used method hotspot. So immediately JIT compiler compile that method and generate the corresponding native code. Next time JVM across the method call, then JVM uses native code directly and execute it instead of interpreting once again so that performance of the system will be improved. The threshold count varies from JVM to JVM. Some advanced JIT compiler will be recompile generated native code if count reaches threshold values second time so that one more optimized machine code will be generated internally. Profiler part of JIT compiler. It is responsible to identify that hotspot. G will interpret total program at least once. JIT compilation applicable only for repetition required method, not for every method. Java native interface JNI. JNI act as a mediator for Java method call and correspond native library. That JNI is responsible to provide information about native library to the JVM. Native method library. Native method library hold native library information like interpreter, just in time, intermediate code generated, code optimizer, target code generator, machine code, and profiler. Simply profiler used for get the hotspot of that garbage collector. Simply garbage collector. In our C and C++, we use new and delete keyword to allocate and deallocate the memory. Simply in that we do not have anything like that. Garbage collector do it manually, automatically. And C program is responsible for both creation and destruction of object, usually program and regulate and destruction of due to the accuracy of the point for it. Certain of new objects sufficient memory may not be available. Entire program will terminate abnormally, causing out of memory errors. But in Java, the programmer need not to be care for all those objects which are no longer in use. Garbage collector destroy these objects. The garbage collector is the best example of daemon thread. Daemon thread is that runs background in your background. Main object of garbage collector is free heap memories. Let's discuss daemon thread in depth. What is daemon thread? G daemon thread. Daemon thread is a low priority thread that run in background to perform tasks such as the garbage collection or housekeeping. Simply, so we can simply call Gym as a daemon thread. So where we have, but in Java program, you need to be careful. No longer use garbage to destroy this. Garbage is best part of the is running background. Main object of garbage is to free heap memory by destroying unreachable object. An object is said to be unreachable if it does not contain any reference to it. An object is said to be eligible for GSE if it is not unreachable. The way to make an object eligible for garbage collection, even though programmer is not responsible to destroy useless object, its recommendation to make an object eligible for GC. It is no longer required. An object is said to be eligible for GC if and only if does not contain any reference variable. The following various ways to make an object eligible for GC. When object does not have any reference variable, then object is eligible for GC. So let's see. Student S1, new student, student S2 is equals to new student. To make object eligible for GC, its reference variable equal to null. So it's become for garbage collector to delete this. Reassigning the reference S1, S2. S1 is now pointing to new object. So previously object pointed by reference variable is equal for GC. S2 is first to S1. Object created inside a method. Inside method eligible for GC. Two methods. Simply you can see this code and you will get that. Here we get here we have one static variable of class one type now pointing to one object and there is also a local. And new after completion of M1 there will be one object exit for JC because local will be destroyed but not static variable. In this example you can see ice island of isolation. In this example you simply see that I is instance variable of type test in main where we can object then very for every object instance variable will be created. Once object is made eligible for GC, it may not destroy immediately, but by the garbage collector, whenever JVM runs the garbage collector, then only the object will destroy. But when JVM runs garbage collector, We cannot extract, but we can request JVM to run garbage collector. There are two ways. Simply use system.jc method. System class contains static GC for requesting JVM to run garbage collector. Using runtime.get runtime.gc method, runtime class allows to the application to enter the JVM which application is running. Hence, by using its GC method, we can request JVM to run garbage collector. But there is no guarantee that any one of the above two method will definitely run garbage collector. So just before destroying an object, garbage collector called finalize method on the object. Just before we finalize method on the object to perform cleanup activities. Once finalize method complete, garbage collector destroy that object. Class file structure. So let's see the class file structure, and after that we will see the sandbox model, and then we will move on to the identifier. So in our next video, we will cover the rest of the topic, class file structure and